Hi everyone, welcome back. So in the first mission, we tried to secure this front gate so that the intruder can be detected from the front gate. Now, what if the person has some ladder like this and is able to make it through inside over the fence? So our next mission now is to secure this fence. The same can be applied to all the fences, but for now we will try to secure this fence so that if intruder tries to jump over the fence, it can raise an alarm. So that's going to be our second mission. So the parts that will be needed are a tower block, IR sensor or gate, hex invert gate. This IR sensor has 3 pins: VCC, ground, and output. So we'll give 3.3 volts here, and the output will be low whenever an obstacle is detected. How it detects an obstacle is this is an active IR transmitter. So it transmits the rays, and whenever there is an obstacle, the rays get reflected, and that is sensed by this receiver here, and that in turn tells that there is an obstacle in front. And depending upon the range that is set at the potentiometer, so we'll use that. If you want to learn more about this IR sensor, it's on the top right corner link. The reason we need these two chips is that we have two inputs now, one coming from this sensor and the other from IR sensor. So in order to know when to trigger the buzzer, we need these two chips. So if you consider magnet as A and IR sensor as B,
Let's look at the truth table once. So all the time the buzzer will be on is either when the magnetic sensor gives 1 or the IR sensor gives 0. So IR sensor gives 0 when it detects an obstacle, and magnetic sensor gives 1 when this fence is open. Now let's go to the circuit diagram. So we have a quad OR gate at the left and a hex inverter on the right. So the input from IR sensor goes to the inverter, and the output from the inverter is fed into the OR gate, and the second input from the OR gate is coming from the magnetic sensor. So the output of the OR gate will now go to the relay input, which in turn triggers the buzzer. So that's how the circuit is, and let's see the connections once.
when the door is closed, the read sensor is active and the switch is on. That in turn gives 0. But when the fence is off, so this will be a dangling wire. So to reduce that, we have kept a pull-up resistor here. I am using 3.3k. So from 3.3 volts, I have kept it to the same pin as that of the other terminal of the sensor. So that it's always high when the switch is off here, and it goes to ground when there is an connection here. So for negation, we are using the hex inverter, which will take the input of the IR signal here, and then the inverted output is shared to the OR gate. And the OR gate has two inputs, one from the magnetic sensor, one from negated IR sensor, and then the output is given to the relay. So I'll be placing the tower here so that I can detect the whole fence, this complete fence. And now let's make the connections. I place it here. Let's make the power supply connections. So positive will go to the positive terminal, negative to here, and this will go to then hex invert. Let's test.